Hello and welcome to FRP Bowling, the classic kata in RxJS and CycleJS. We're going to be developing using functional responsive programming methodologies and agile programming methodologies an application for the web that will permit a bowler to maintain and keep a score for a game of 10-pin bowling. In a game of 10-pin bowling, the bowler goes ahead and rolls a ball at a series of 10 pins. If he gets all those pins, it would be called a strike, and it's scored in a particular way, which we will see in a minute. If he misses any number of the pins in a frame, he gets a second roll, and as you can see, the second roll will only be for the remaining pins with everything else disabled. And can score 1 or 2 pins, however it is, and the scores are maintained in a particular way. We'll talk about that in just a moment. There's a special scoring style. A 0 is shown as a hyphen for a gutter ball. A spare, which is when you use the second roll to get the rest of the pins, is represented as a slash. And 10 pins at the beginning of a frame is called a strike. And as you see, there's a little space over here between the beginning so that the box is completely filled. The scoring process is actually fairly straightforward. If I roll 2 pins, I score 2 for that frame. If I roll 5 more pins, I would score 5 plus 2, or 7 for that frame. If I roll 4 and then 6, you notice also, first of all, if I roll a 4, I get the 4 pins showing, but we don't show just 4 here in this square. We keep a running total, so it's 7 plus 4 is 11. And if I get a spare, notice that the score disappears because we do not show a score for a frame that isn't yet completed. That is to say, there is a bonus for the bowler who hits a spare. He gets 10 pins plus the amount he gets in the next roll. So if I roll a 9, almost a strike, I get 19 for this frame plus the 7 to make 26. And then for this partial frame, I get 9 plus 26 is 35. Now once again, notice if I get a spare, it will erase that 35. And if I get a 10 on the next frame, I would get 20, 10 plus the 10 for the next roll, and that would make 26 plus 20, or 46. Now a strike is scored even better for the user. I get 10 pins plus the very next 2 rolls. So 10 plus 5, I'm still not showing a score because all the bonus is not present. And as a result, you always leave that blank until I've rolled the second roll afterwards. And that would be 10 plus the 10 for the next frame is 20 plus 46 is 66. And notice we're not showing a score here because we have a pending spare. I show the 9 and then that works. If I don't have a completed spare or strike, that's called an open frame, then it'll just score that frame as 9 plus 85 is 94. If I roll 2 strikes in a row, I get to roll a third strike. That would be called a turkey or a triple. And that's 10 pins for this, plus the next 2 rolls would be 30. And then that would be 94 plus 30 is 124. I can go ahead and strike out to see the end of the game, and notice after the game is over, all of my buttons for the game are grayed out. I also have a feature here in the game to undo my last roll or my last action, and to redo those that I have undone. And then finally, I have New Game, which gets me to start over, which, by the way, can be undone as I've done it. And that is the application that we'll be doing. We're going to be writing a number of modules, and we're going to be doing it with what we call test-first development, which I'll explain in a little bit. But before I do that, I want to show you what those modules are and how they work. Essentially, I'm going to have 3 modules that we're going to be writing for the application itself. These are going to be unit tested using TDD, or test first development. The first will be the score, which is simply what's going to be showing the number at the bottom. Notice that the longer the game, I might actually have fewer frames, because although I have 20 here now at 2 frames scored, when I hit a 5, I only have 1 frame scored. So that's a little trick we need to be aware of and need to handle properly. Secondly, we're going to have, and we'll call this thing the scorer, of course. And then what we're going to do is we're going to go ahead and write the program that provides the annotations in these boxes here atop there. And we're going to call that the displayer. And in both of these, it's going to take a stream of rolls that are given by hitting these buttons, and it's going to return, in this case, a stream of scores. The displayer is going to take a stream of rolls, the same stream of rolls that the scorer gets, and it's going to return a stream containing a singleton string, a stream of a singleton string that will represent the characters that will go in the boxes along the way. Notice that the displayer is going to have space X for strikes, except in the 10th frame, you'll see it won't have the space before those, and that'll be the trick. Then we're going to write the program that actually makes the buttons gray out, so that if I hit a 4, it knows the next frame to make 7, 8, 9, and 10 become disabled. We're going to call that the enabler, because it's going to keep track of what's going on. So we have the scorer, the displayer, and the enabler. And then we're going to go and proceed to write an application, the front end, in RxJS. Again, we're going to be doing all of this with TDD, and that will be the subject of the following screencasts. We're going to go first and talk a little bit about test-first development, and then we're going to go straight into building the scorer, the displayer, and the enabler. So, without further ado, what is test-driven development? And so what is this test-first development? It's an agile methodology for building code and at the same time a suite of automated tests that verify that the code is working. But it's done in a way as to actually assure that the application is behaving in accordance with it, rather than writing the tests after the fact as part of a quality assurance at the end. We're going to do our quality assurance up front. We are going to follow a discipline which will not permit us to write a single line of code until we are first read, which is to say that we have a failing test to solve before we can move on. Now, this test should be simple and just the minimal next thing that is obvious to do, because that will make solving the problem that much easier. We don't want to say, here's a specification of the whole thing, make it green. Rather, we're going to be doing it a little bit at a time. We won't actually have an application working or even existing at any time, because we're not allowed to write any code until first we are read. And so we actually will begin a process of writing a test first, and then solving problems and bugs and syntax errors and whether files exist, just to go until we're actually at the point of having a read test just for the subject matter of the application. I call this fake it until you make it. We'll begin with the process of writing a test and then trying to get enough of the structure of the application together so that we can actually start building our code. Then we solve the problem, make the test pass, and we are green. Green means that we have solved the problem and done all that's necessary. And now we are going to go to the next step, which is either to write another test, again, the simplest possible test to move forward, and to refactor. Now, in going green, we're going to follow a process of actually solving just what we need for the test. We're going to do the smallest, most minimal amount of code that could possibly work. We're not going to worry about how good the code looks and how effective it's been. We're going to do that later. After we have made the test pass, we go through a step of refactoring, which is, again, to write code to make it prettier, more effective, more beautiful, but not to add new substance to it, just to make it more effective. And we worry about it now to do that. We also will refactor our tests if they're difficult to understand or if there's duplication in code that's actually confusing to the test reader. We're going to solve that by refactoring. And then finally, once we've refactored, we'll test again to make sure that we still have a passing test. And that's why we can refactor with confidence, because we know that we've got tests that will tell us whether we've broken or made something wrong. And then finally, when we're done with all of that, we write the simplest test to move to the next step. We are read, and we repeat the cycle. This is test-first development, and we will follow this discipline rigidly as we go ahead and proceed. In running these tests, we're going to use a bespoke test driver, which was built just for these screencasts. What it will do is it will allow us to display the results of our tests in the browser's console, and it'll show the results as they're done. And we will see how that works later on. But let's quickly understand, at least just review the operations that are provided by this test driver. And then we're ready to get started writing our score. Our C development system includes Test Suite, which is a browser-based test function that allows us to do test-first development in the browser. It includes test, which is the external function that includes all of our tests. It starts with a string for its first parameter, which identifies the tests, and then followed by a function, which includes all the assertions to be tested. There are two general expectations that are included. To be, which is going to pass. It's a test that passes when the actual value, whatever it is equal to expected value in the JavaScript sense of 3 equals, equal, equal, equal. There's to equal as an expectation. This is going to be similar to be, except that it passes whenever actual is similar to expected in like an array, in the sense that it would have the same JSON representations, because arrays are not ordinarily equal in the JavaScript sense. The next two functions deal with observable streams, and toMarble passes whenever the actual stream has the expected marble diagram, in ASCII marble diagram. And expected to be stream of passes whenever each element of the actual stream, each item, is going to be equal in the JavaScript sense to expected. It's particularly useful when you're doing tests of something that is an actual stream that contains a single element. And then finally, there's a utility function, marble2stream, which will convert the ASCII marble diagram into a stream, and that's useful for setting up tests. And now let's begin to develop our score.